All right, good morning. So today what I want to be covering is Module 6 of the CCNA exam, which is Automation and Programmability. So we'll go ahead and cover this topic here. If we look at this first slide, these are the topic areas covered in Module 6. Explain how automation impacts the network management, compare traditional networks with controller-based networks, describe controller-based and software-defined architectures. We're going to go over overlay, underlay, and fabric. We're going to look at the separation of the control plane from the data plane, look at north and south APIs. We're going to briefly go over explaining AI. So talk about machine learning, generative, and predictive learning in computer networks. Just a brief primer on AI, which is a new topic added to the exam. We're going to describe the characteristics of REST, also look at HTTP verbs such as CRUD, recognize the capabilities of management mechanisms such as Ansible and Terraform. Terraform is a new addition to the exam, so we're going to be covering that in detail. And last but not least, we're going to be trying to recognize the components of JSON. So when we look at some of the benefits here of automation, we want to look at the impact of automation here. So what it says here on the slide, it says reduce human error and high reliability. So automation actually minimizes mistakes and typos. So common typos we make, like typing the wrong VLAN in the configuration. If you use automation, it'll put more consistent configurations to devices. It talks about operation efficiency and speed. So a lot of times if you're doing repetitive tasks, you want to perform software updates, do backups, it will do that for you. So something you're doing over and over and again, you could set up a script to go ahead and do that. If you want to go home at night and do an offline upgrade, say at 2 o'clock in the morning, automation will actually help you do that as well. Scalability and agility. So as your network grows, a typical traditional network grows, you need more people to manage it. So the scalability, your network can grow. You can actually create more automations to make it easier to manage with the same amount of people. So new devices, rapid deployment, adaption, network changes can all be handled through the automation. What's it here say here? Proactive management. So you can automate tasks using AI and machine learning. So with machine learning, you can actually look at your network. Over time, the machine learning will learn how your network operates. So let's just say you have congestion or some type of issues, security issues. It will go ahead and look at the static way the network operates, and when it learns of drastic changes, it can alert you to those. And last but not least is standardization. So let's just say I'm configuring parts of your network and you're configuring parts of your network. We may not do it the same way, but if we use an automated script and you can go ahead and create a standard way. So if you're creating VLANs and I'm creating VLANs, the automation script will create it the same way each and every time. All right, so now we want to look at the difference of traditional networks and controller-based networks. So when we think of a traditional network, we think of what we have here. We have our routers, we have our switches, and you'll log into CLI to control all those components. But if we use a controller-based network, as you see, the controller sits in the middle. So the controller will actually update all the devices. One thing we want to consider about the controller is that there are two different flavors. So you have the Cisco APIC, the application policy controller, which you use in the data center, and you also have the Cisco DNA Center. I believe it's changed to Catalyst Center now. but the Cisco DNA Center actually is used for enterprise network. So if you have your enterprise network, you can actually use that to control your networks as well. All right, so let's talk about the network fabric. So in this example here, we actually have what we call a spine leaf network. Now, when we think of the fabric of a network, that's it, is the actual cables, the hardware that the application rolls across. So when we think of a data center, the way that we deploy data centers now is using a spine leaf network. If you look at the top, you have your spine nodes, and at the middle, you have all your leaf nodes, and at the very bottom, you have these nodes, which are actually your servers. So those servers would connect to each switch, leaf switch, which, if you remember the enterprise model, that would simply be your access layer. So you connect all your servers into the individual leaf switches. As you can see in this diagram, the leaf switches are connected in a bow tie fashion, where leaf switch 1 will connect to server 1 and server 2 for redundancy. Same thing with server 1. It will connect to leaf switch 1 and leaf switch 2. Typically, we think of leaf switches as top of the rack switches. So if you imagine a data center and rows of racks, in each rack would be your leaf switches. Now, your leaf switches are connected to your core switches, or excuse me, your spine switches. And your spine switches is where all the intelligence resides. Now, one thing to keep in mind about the spine switches is that the spine switches do not connect to each other. Spine switches only connect to leaf switches. Now, keeping that in mind, the leaf switches, they only connect to spine switches and the server nodes where your access devices will lie. So for any communication, if you're going from one leaf switch on one side of the data center to a leaf switch on the other side of the data center, that communication would have to go through the spine switches. Think of it like a tree, right? You have your branches and then you have your trunks. And off each branches are leaves. So your leaf switches connect to the branch, and then for it to go on, it would go on across that one. All right, so next we have what we call our underlay and overlay. Now, when you think of the underlay and overlay, this is how the next generation of networking will work. So when we think of our underlay, it's just what we think of now today as our switch fabric, the traditional switches and routers, cables. That's where all your traffic currently resides on today. But when we think of the overlay network, it is a virtual network of tunnels like VXLAN or GRE built across the entire network for virtualization. So if you think of an individual session, imagine you on your computer and you're logging into your network management system across your network. That would be a session. Or you have a internet session to cisco.com. That would be a separate session. Each one of those sessions would be going over a VXLAN, which stands for Virtual Extensible LAN. So each one of those applications would reside across the network. And the controller would look at not just the traffic, but each of those individual sessions in those individual tunnels, VXLAN in this case, and then it will provide QoS for those individual sessions. It will provide security for those individual sessions. And that is the way the controller will look at the network devices and the network traffic. It would look at on a session per session basis. Now, for a little bit more clarity, I've added this other slide here, and it just kind of shows you the difference between the overlay and underlay network. And we look at on the right, our underlay network, we think of components like your hardware, your routers, your switches, the physical links between them. We want to think of what is being provided, which is the actual transport. We want to think of our routing protocols, which provide the traffic, so OSPF, BGP. And then we want to think of the scalability, so if you want to add additional sites, you have to add additional hardware. So the scalability is built on the hardware and the rigid configuration of your constraints. Now, if you look at on the left is the actual overlay. And when we think of overlay, we want to think of the software-defined networking. And we talk about the software-defined networking, we're talking about tunnels, virtual nodes, virtual routes. When we think about that, we want to think about the purpose. The purpose provide logical, isolated, secure communication between devices. So each session is secure, you have mobility, and each session could be policy-based. So, Kim, if you need to get into a session on one application and you had access to it, and I want to try to access it from my application, I don't have access to it, that you can actually create policies to prevent that. We think of the protocols, we think of, like we said, GRE tunnels, IPsec tunnels, which is secure, and VXLAN. So it's flexible, very scalable, but most important to remember, it's software driven. So the controller would actually control that. Now, here we're going to talk about the difference in the different planes on the network. So in this example here, we're actually looking at the data plane. Now, when we think of the data plane, what do you think of? You should think of the actual hardware, the routers and switches that resolve there. So the data plane's responsibility is forwarding all traffic from one interface to another. So when we see a message come in, it needs to go into switch one, go into router one in this case, and router one's going to send the packet or the frame onto switch two, router two, what have you. So the router looks at the message, looks up the routing table to see where it goes to, and sends it on to the next hop. So that's the data plane, basically the hardware that forwards traffic from one device to another. Now we think of the control plane. Now here, the control plane operates within the router. So when we think of the control plane, we want to think of things like routing protocols. So let's just say you have OSPF running on your router or BGP. Those would be part of the control plane. It actually controls where the traffic goes. So not just the interfaces and the data plane, but the control plane would actually control the traffic. So if you have a switch, frame comes into a switch, the switch looks at the MAC address, then looks at the MAC address table to tell the frame where to go. On a router, you think of a packet comes in, the packet comes into the router will then look into the routing table to see where that packet must go. Those are parts of what happens in the control. Now here we have the management plane. So we talked about the control plane. We talked about the data plane, but now when we talk about the management plane is basically how it manages the device. So we think of it as the overhead. So if you ever logged on to a device to make changes to it, think of your CLI into the interface, the console port. If you telnet or SSH into the device, that would be something you would use to manage the device. We also want to think of management protocols. So when we think of our logging, syslog, that is a management plane initiative. Our syslogs take the logs from the router. We think of simple network management protocol, SNMP, that would be part of the management plane because that's what we're using to manage the device, to control it and let us know of alerts. and also NTP, our network timing protocol. These are things that happen at the management level, and this would be part of the management plane. Now, to tie it all together, we want to look at SDN, software-defined networking. So we see in software-defined networking on the SDN, they have it set up in different layers. You have your infrastructure layer, which is where your routers and switches reside. So I want you to think of the data plane. You have your control layer, which is where you're actually controlling lines. As you can see in the middle, it says SDN controller. And that's what I want you to think of the control plane. And at the top, you have your application layers. So your business application, cloud orchestration, SDN applications, how you actually interface into the controller to control your devices. That is what is considered the application plane. So think of those when you're thinking of SDN. So let's go a little bit more deeper in how SDN interfaces with our network devices. So here we have our network devices in this slide here. So we want to look at how the network operates. As you can see, the controller is in the middle. So you have your controller on the bottom. Under the controller, you have your hardware devices. And as you see, a router has a management plane, control plane, and data plane. But the controller is going to alleviate some of that responsibility. And as you see above the controller, you have your applications. So let's look into detail. So one of the things that we do with the software-defined network is we distribute the control plane. So a minute ago, we talked about what the control plane is. So on each router has its own routing table. On each switch has its own MAC address table. And those tables are helping responsibility for telling packets or frames where to go. So imagine if every router on your network, all of its routing was done at one centralized place in your SDN controller. That's what is provided by the software-defined networking. So all your routing would be done by the SDN controller. Same with your switches, lookups of MAC address, your MAC address table. So the frame forwarding, determining and making decisions where a frame will be forwarded to, that is alleviated from the switch, and the controller would make those decisions. So the controller would make those decisions and would send those instructions southbound down to the switch. The controller makes routing updates, and it'll make those route changes and send those instructions down to the router. And all the router simply does is take the packet in interface 1 and send it out on interface 2 onto its merry way. Now, next we have API. Now, API stands for Application Programming Interfaces. Now, this is where the data, the software talks to each other. So imagine you have a Cisco router and you want to be able to control it. Well, your controller would have to share an API, an application program that speaks to the Cisco router. So if the API on the controller can speak to Cisco router, they can communicate with each other, and that's where those control instructions come from. Now, if we look at the controller, we notice below the controller are all the network devices. All the network devices are below or southbound. So when we talk about southbound, we want to talk about our southbound interfaces. Now, when we talk about southbound interfaces, we're talking about SPI interfaces that are used to control our networking devices. So if we want to send information to a device, a number of SPIs we can use is things like OptFlex, which is a Cisco proprietary SPI, a lot of times used for Nexus devices such as a Nexus switch. We think of OpenFlow, which is an non-proprietary SPI used to control network devices. Cisco also uses Cisco 1PK, which is for their platform kit. So if you've ever gone on to Cisco website for their application data website, you can use that there. And then also the last but not least is netconf. Netconf is a commonly used networking South SBI that's used for control of hardware networking devices. See, the next example is centralized control plane. We talked how all the controller would do all the routing and switching and centralize into the device, and all of that's being managed at one area. And the reason why it's highlighted is because that's the benefit of a software-defined network. You have one place that controls the entire network. So instead of having a technician log into router one, a technician log into router two, router three, now all you have to do is all your commands are sent from one central controller. We talked about OpenFlow. Now we want to talk about our northbound interfaces, NBI, northbound interfaces. So if our routers and switches are south of the controller and the controller is central in the network, then above it is the actual applications. Now, what are applications? Glad you asked. Applications are components that we use to actually send instructions to the controller. So we want to send updates, we want to send changes. We may even have another device that sends messages to our controller for updates, for changes. So we may have a policy manager or a security device, a central security manager. Those functions can be communicated down to the controller to say, all right, please institute this policy on our network. So the way we as users would interface into the controller is through those applications, and those applications are instructions are sent via northbound interfaces. So common what's an example? Okay. REST is one, and I'm kind of lost on it now. All right, so let's go on to our next slide. All right, here we're going to talk about AI. Now, when we talk about AI, we're talking in reference to the different components of AI. As you can see here, we have listed a number of different components. So at a 3,000-foot level, you have AI, but under AI, you have a bunch of different components. So we want to think of AI as a broad umbrella that covers a lot of areas. So under AI, you have machine learning, and under machine learning, you actually have supervised and unsupervised learning, deep learning, and then we're also going to talk about predictive and generative AI. So let's go on to the next slide. So when we think of AI, we want to think of AI simply as we're trying to take on the left human intelligence and put that into a computer, some type of way to do computations. So when we think of that human intelligence, we want to think of learning, reasoning, and making corrections and instructions. So that's what AI does. It basically tries to take a machine and create intelligence to think of things to help support humans and the way we understand things. All right, so machine learning. Hello? I'm hearing the echo. All right, never mind. All right, so when we think of machine learning is a subset of AI. So we think of artificial intelligence, machine learning is a subset of AI. And what machine learning is, allows a computer to mimic uh, human behavior. So it's basically the way it learns. It allows a computer system to self-improve, look at performance, also allows a computer to use different algorithms to recognize patterns to execute instructions based on things that it's learned. So if we have those instructions and we teach the computer properly, it will learn the way humans perform functions, what's the NLP, normal language, and physical actions, and it'll perform those actions for us after it's learned over time. So we want to think of where will we use machine learning in a network. We want to think of traffic classification. So we see traffic coming in, the machine will look at the different traffic and be able to classify it, but also it can look at that traffic and look for anomalies in the traffic. So let's just say you're used to getting this type of traffic all the time, and all of a sudden you see strange traffic from some other place, say malware or a nefarious user. It can actually look at that traffic and say, hey, this doesn't match our normal pattern. Now that it knows that, it can also use that for intrusion detection. So it can look up and say, all right, here are a list of authorized users. Here's users that typically use that, and here's their typical use pattern. But now I've seen this strange signature of a strange user from a strange land getting onto our network. So I can just alert that, hey, we may have an intruder here. Also, it can be used for capacity planning. So let's just say we notice that right after lunch, we see spikes of traffic going to our router one. That may say, hey, we may need to increase the capacity on router one, or we may need to implement different QS policies during this time of day. So machine learning actually allows the machine to go in and look at what's typically going on and manage it by looking at it over time to figure out what's going on and how we can actually act upon that. Now, what types of machine learning are there? Well, there are two types. We have our supervised and unsupervised learning. Now, supervised learning is simply learning that you train a computer on labeled data. So basically, you take data, you classify it, and you say, all right, and you feed that data into the machine. So you actually supervise the training of the actual AI. Unsupervised learning is just that. AI will just look at unlabeled data, so data you haven't classified, and the machine learning will be trained on just looking at the raw data. And over time, it will learn the patterns of the data. And if you use specific algorithms, it assigns and classifies the data based on the performance over time. So the more time that it looks at the raw data and the patterns, it will develop the tendencies of the network and act upon those. Now let's talk about AI. There are two types. You have generative AI, which we're talking about here. So when we talk about generative AI actually takes information and we can create from it. So when you think of generative AI, think about like Chat GPT. So if you ever see people make these videos online or whatever, or you ever go in and somebody says, hey, Chat GPT, write me a term paper on the flight of seagulls or whatever for my college class. That is generative AI. You train it by putting in data and it will go ahead from that data. So in this example, they're actually using different dogs, right? So it's saying, hey, AI, here are a bunch of pictures of dogs. Can you create for me a generated picture of dog? So what it will do is take real data, like photos of dogs you fed into and taught it, and then it will create by looking at the dogs and how they are, and it will create fake photos of dogs. So if you ever see those fake photos of AI, Michael Jackson, uh, walking down the street with whoever, and you say Michael Jackson's in there, this is how they actually do that. So they use generative AI. Now, next we have descriptive AI. So in our Cisco, the earlier slide called it preventative AI, but descriptive AI, preventative AI, the same thing. And when we talk about descriptive AI or predictive AI, excuse me, predictive AI is just that. It's trained on data. So what here in this example, predictive AI will look at trends over time and then try to predict that. So think of kind of like a weatherman or something. I look at how the weather is and trend is over time, and I'll make a prediction. Then this example is taking a bunch of photos here. So they're taking photos of dogs and cats. So as you can see, the AI is being fed photos of dogs, and it's giving those a binary 0. So whenever a 0 comes in, it knows that that picture is a photo of a dog. And when it sees a binary 1, it knows that that picture is a photo of a cat. Now, it will receive photos over time, and then it will predict, like, okay, because of the data I'm receiving and the classifications, I've noticed a pattern. So I know I'm 87% likely to see my next photo be a cat. And that's how descriptive AI works. So we want to think of the key components of AI. We want to think of machine learning, the different subsets of AI. So when we think of machine learning, we want to think of those components. Let me go back to my original slide. So we want to think of the components of AI, machine learning under that, supervised, unsupervised learning. What is the difference between those two? And then we want to think of deep learning, which I didn't cover, which goes into neural networks, which is probably beyond the scope of this CCNA. And then we want to think of predictive learning. Are we going to try to predict the future, or do we want to generate a photo of a dog? So those are the components of AI. All right, so let's talk about REST APIs. So here, when we talk about REST APIs are used with JSON. So we talk about JSON as part of our programming package and SDN and controller maintenances, but we want to look at SDN controllers using HTTP verbs. So if you are familiar with websites and how websites work, you have particular components to update your websites or whatever. So when we think of our well-known HTTP verbs, we use post, get, put, and delete. So that's how you update and create and make changes on a website. But when we look at the CRUD, which stands for create, read, update, and delete, that is how the APIs function in a REST API. So when we want to see, which operates very similar to HTML, we want to see that create is the same as the HTTP verb post. So if you create something, then you're going to create a post. Read something, you want to get data from a device, you want to read it, that's the same as the HTTP verb get. If you want to make a change, an update in CRUD, then you want to do the same as an HTTP put data there. And then in CRUD and in HTTP, both delete are the same. All right. So now we're going to talk about Terraform. So Terraform is a brand new component of the CCNA exam. If you are familiar with cloud programming, you may have heard the term infrastructure as code. That's what a Terraform is a tool to use infrastructure as code. So imagine you want to build out a network, you want to build out a network in the cloud, then you would use Terraform. So Terraform is an open source tool that allows you to build out your infrastructure. It uses a wide range of different, excuse me, it uses a wide range of different cloud providers. So not just AWS, it uses Google Cloud, Microsoft Azure. So the different types of cloud providers, you can use it as one place to control your cloud, but also control what components in Terraform are being controlled. Now, if we also look for the CCNA exam, they wanted to include this in exam syllabus. So because we are moving more to the cloud, so we want you to understand how to manage a cloud infrastructure. So let's go into more detail. Also, um, Terraform uses a language called HCL, which stands for HashiCorp Configuration Language. HashiCorp is the company that created Terraform. So whenever you think of Terraform, you see HCL. Remember, Terraform runs on HCL, HashiCorp Configuration Language. All right, so here's Terraform. So basically, if you look at it, we talked about HashiCorp. They actually have a website where you can actually play around with it so you can get familiar with it. So at Terraform.io, you can actually put in instructions just to kind of test and perform. But what is Terraform exactly? Well, Terraform can be used for infrastructure as code. So think of if you actually have a cloud virtual network. You want to spin up those virtual networks. Terraform can actually do that in code. So remember, in the cloud, you're working on virtual applications. So it's not like here on land where we're using real routers, real switches, what have you. This will actually build out your entire infrastructure for you, from your EC2 compute instances to your virtual routers, your virtual firewalls, even your policies on how you're going to allow traffic get from one point to another. Terraform allows you to build out that whole virtual infrastructure. Now, what are some of the benefits of Terraform? Well, like I said, it supports multiple cloud providers. So you can use with the three listed here. It also allows you to automate some of the many tedious processes that you are when you're setting up your virtual networks. So I used the process before. If I'm setting up an EC2 instance and Joe's setting up an EC2 instance, we may not set it up the same. It allows you to manage those all the same, and also allows you to provide consistency of configurations. So me and Joe may not be creating them the same. You can actually create a policy on, like, if you're creating, depending on what the requirement is, you will create EC2 instance type 1, the compute engine. So the configuration will be consistent across the network. You won't have a small instance here and a large instance there. They will also be the same. Also, it reduces configuration errors. So anybody who's ever been on a keyboard and configuring a network and ever fat fingered a command or whatever, Terraform reduces that because you're putting all of the programming on the front end and then going to execute it on the back end, and it does it all the same each time. Now, how does Terraform do? So from a 10,000 foot level, these are some of the instructions. So when we think of Terraform, it's just that it initializes everything. So let's just say you want to create a new network. You'll initialize everything and work from scratch. Then you'll generate a plan on how you want to execute it. What it will do is, from your plan, create those applications and changes. So let's say you already have an existing network and you will not want to create a new network, but you want to add some router devices, you want to add some firewalls, you want to add some more networks, and you want to add some EC2 instances, compute instances in there. Terraform will actually do that for you and apply those changes. And then if you already have current changes on there, think of you have a change running, your version 1, you come up with a version 2 change. What Terraform will do is actually destroy that version 1 and write over it version 2. Now, this is a key thing to keep in mind because, from my experience, we were using Terraform for our AWS network, and and the edict was you were supposed to manage everything through Terraform. Well, one of our engineers went in and added some more compute engines into our EC2 infrastructure. So he had a bunch of different servers, virtual servers running on that he added manually. Now, these manually added devices weren't in Terraform, and people using Terraform did not know about those devices, so they didn't input that. So when they decided to make another version change and they wanted to add additional changes, what Terraform did is it destroyed the version of the network that it knew and recreated that network with the changes that it knew of, plus the new changes, which erased the changes that it didn't know about, which were the ones that were added manually. So I kept getting a bunch of alerts, hey, Kevin, I can't get to the server anymore. And then I found out, well, the reason why is because it wasn't placed in Terraform. So that's a key thing that I learned that I want you guys to keep in mind when using Terraform, that it does that. It terraforms that world. It will destroy the old one to create a new one. All right, so here we look at an example of Terraform code. If you're familiar with the CLI from AWS, this will look very familiar. So if we look at the code, it actually defines what we're creating. So as you see here, they're trying to add an additional EC2 instance, but when you're creating an instance, you need to know, well, where are we going to put it in? What region? As you can see here, it says region equal US West. So that's where they're going to put it in. They actually have the EC2 instance, the resource name. As you see, the type of EC2 instance they're using is a T2 micro, which is smaller one. And then as you see at the bottom, they're requesting a public IP address for that instance. So it's not going to be a private instance. It's going to be an instance that's accessible through the public internet. And this is the code that will go into Terraform that when you create the next version, it will execute it, and then your new EC2 instance will be there and be available for you to use. And that is Terraform. Now we're going to talk about Ansible. So if you're familiar with network configuration tools, Ansible is the one that's key. We were using Chef and Puppet in the previous version of the CCNA, version 0, but now in version 1, Chef and Puppet is no longer on there. So the only server-based application that we're going to be using in this version of the CCNA exam is Ansible. Now, unlike Terraform, which is used for virtual applications, Ansible is what we're going to use for our real applications. So in this case, you have a couple Nexus devices, you have your Ansible server. The Ansible server will actually do configurations into those devices. As you can see, Ansible is backwards compatible to a number of different Cisco devices because it connects to them not through any type of API, but actually log in via SSH, right? So we'll connect to the API via SSH and log into the device to make the changes. Now, how does that work? Well, to do that, you come up with a playbook. Now, a playbook is a list of configurations and instructions that you want to install on your different devices. Now, how do you determine which devices you're going to install those instructions in? Well, you also have to come up with what we call an inventory. And an inventory would be a list of devices that you want to make those changes to. So the playbook would be the changes, and the inventory would tell Ansible which changes to execute those playbook instructions on which devices. And one thing that can remember is that Ansible runs on YAML, which it says here, YAML. I'm not sure if it stands for YAML ain't a markup language, but YAML is the code that Ansible runs on. One thing to remember is that Ansible does not require an agent. So when we think of an agent, that means software that runs on Ansible that have to run on the server that would also have to run on the host. Ansible doesn't do that because it can SSH into each device. Now, what would that configuration look like? Well, here's an example here where we have what the configuration would look like for one of our nodes here. So if you see here on the left, a little bit similar to CLI. As you can see, it shows the configuration, shows the host name. In this case, they're configuring interface. They're putting description, IP address, setting it to up, and then they're actually adding an IP helper address. And then they actually say what interfaces these commands are going to be placed against. So that's just a sample of what the Ansible information would look like. All right, now here we actually have a side-to-side comparison of Terraform and Ansible. So just consider, remember, Terraform's primary is primarily for infrastructure. So when you think of infrastructure, I want you to think of cloud, right? So creating and managing resources, where Ansible focuses on management of hardware. So installing, configuring software on existing infrastructure. So where Terraform can actually create a virtual router, can create a virtual EC2 compute instance, create a virtual firewall, Ansible can't do that. Ansible does that with already existing hardware. So we see the primary functions, use cases. Here it says creating and managing infrastructure for Terraform, where Ansible is configuring software and existing infrastructure. So if you want to do a software update, Terraform's infrastructure's code is its focus, where Ansible is to automate tasks, software deployment, and to deploy configuration. Terraform works with multiple different cloud providers, AWS, Azure, Google, etc., where Ansible works with servers and applications in different environments. I didn't mention it worked with servers, so server folks work with Ansible, but we on the network side use Ansible for updates of networks as well. All right, cool. All right, so now we're going to cover JSON. So when we think of JSON, JSON is a JavaScript language that we use in our configuration. So if anybody is familiar with, say, Python or programming languages, this should be a little bit of old hat to you. But part of the exam is you need to be able to understand JSON instructions. So we're going to go over these briefly. So basically, in JSON, like in most programming languages, you have two basic structures. You have a collection of name value pairs, and then you have an ordered list. So when we think of name value pairs, we think of what we're going to name something and what it actually is. When we think of ordered list, we think of a list of devices or list of components that we're going to do instructions against. So let's look here for our next one. So in JSON, we have an object. And remember I said name value pair. So in this case, we have two objects here. We actually have our one object. So the object here, it creates your name, which is first name. So the first object, first name, and then the value is Kevin. So first name is like I'm asking you your first name is, and then the response is Kevin. Then the second object is last name, and then the response is the value is Wallace. So when we think of name value pairs, this is how we do. Now, one thing to keep in mind for objects is we always will see these curly brackets in objects. Now, inside these objects, as you can see, they're separated by commas. So whenever you enclose in curly brackets is an object. Now, we can do it one of two ways. We can actually do it this way in a line, but for humans to be better to read, some programmers will list it where they have the curly bracket, they have the first name, double colon Kevin, then the comma to separate it to the next object, last name, double colon Wallace. So that helps it make it easier to understand for human eyes when they're reading the instructions. So that is an object, name value pair. Now we want to look at the next value, which is an array. Now, an array is an ordered set of separated values. So in this case, we're looking at a list of values. And remember that an array is always enclosed in these straight brackets. So when we think of values, think of the exams. So let's just say you want to parse your way through all these exams. So in here, we have our array, our list, and the first object in the first value in the array is CCNA. And the second value in the array is CCNP Enterprise. And then the final value is CCIE Enterprise Infrastructure. So we saw the same thing with the white space where they're listed one on top of each other and they're comma separated. Now remember, an array always is enclosed in these straight brackets as opposed to the object. And last but not least, we want to talk about our values. So values in JSON, very same as most programming languages. Values can be a string, a number, an object, an array, null, which means nothing, or you can do true or false. So these are how you list your values in the programming language to create instructions against that. And as you see here down at the bottom, http://JSON-lint.com is where you can actually play around with a bunch of different JSON values if you want to see if those instructions would actually work. And that is all we have today for our CCNA Module 6 presentation. Hope you guys learned something. Please feel free to forward any questions to me. And thank you very much for your attention. How do I hit stop? All right, how do I stop the recording?